Good morning, Klaus. How are you today?
Morning, John. I'm absolutely fantastic. How about yourself?
Absolutely. Love it when I hear another person say they're absolutely fantastic. And I think
It's
that's
Friday.
actually the best way to start the day. So thank you for sharing and brilliant. Thank you. So, Klaus, we're absolutely looking forward to record your CTO News Thursday vlog series and really get to know more about you. So please can you introduce yourself to our audience, please?
Yeah, I'll do that, John, but I appreciate you having me on this show. I really look forward to this opportunity to have a chat with you, so thanks for that.
No problem.
Um, my name is Claus. I'm Danish. If people haven't picked up the accent, yes, just so you know. Living out of Denmark, I'm the Chief Product and Technology Officer with Unit4, a ERP vendor within the space of people-centric businesses. I've been in engineering pretty much actually my whole career since I left university back in the early 90s and worked inside the enterprise space for the last 20 plus years. And now I'm Unit 4. Before that, I was at Infor, another ERP vendor. And yeah, enjoying working with technology, people, and the crossroads between technology and people.
Absolutely. And the crossroads between technology and people is, I'm sure, something we're going to cover in our discussion today. So let's delve in and looking forward to learn more. So in the first instance, in terms of my first question, how do you adopt cloud infrastructure to contribute to sustainability compared to maintaining on-premise data centers?
So essentially, the interesting thing here is, I think it's just first of all, I think sustainability is a great topic, right? And I believe we have, as tech leaders, we also have the responsibility to make sure that we develop software and systems that actually takes into consideration the footprint that we are through CO2 emission, right? And the good thing about the cloud versus on-premise is that when you're using hyperscalers or any sort of cloud infrastructure, you can go with models that only consumes compute and storage resources when you actually need them, right? Whereas if you have your own on-premise solution, you have to have a certain amount of capacity available, and that certain amount of capacity is mostly aligned with the max you need at any given point. Whereas if you are in the cloud, you can quickly adjust that to match what your need actually is, meaning that when you need less, you turn down for the compute and storage, and then you can scale it back up when you need it, right? And of course, not only is that helpful for the environment because you consume less energy, consuming less energy means less CO2 emission, but there's also a benefit financially because you don't pay for more than you use. So there's a great opportunities both there from a sustainability and also from a cost perspective. Although you need to keep in mind that your software needs to be able to support the ability to scale up and down on demand, right? So you don't get that for free. There's some work aligned with that, but there is a lot of value to this.
Absolutely, absolutely. And I think from some of the conversations I've had with regards to, whether it be sort of cloud and on-premise data centers, etc. I've had conversations around AI and how potentially AI workloads could be influenced with regards to the amount of energy that's needed in whether it be data centers, AI data centers, with regards to NVIDIA chips, and how that might allude to some organizations deciding whether or not a particular AI workload is the best option for their strategy, for their outcomes, for their objectives, based on the costs associated with powering the data centers based on NVIDIA chips, which, say, for example, as one of my good friends mentioned to me, a chap by the name of Steve O'Donnell, who said that an NVIDIA chip, a silicon chip, generates 1 kilowatt of energy, which is about 20 hours of energy. But anyway, that's a different sidetrack and segue. But yeah, thank you for sharing that. Okay, so what are the key sustainability benefits of centralized and decentralized architecture in IT systems?
Yeah, but so the key benefit is centralized versus decentralized. So this is a slightly different topic, right? But I think the way to think about this is that if you have very centralized systems, and your users are sitting in a very dispersed environment, and if the distance is big enough, you actually will run into issues, right? Because you have latency, there's, depending on how far apart the different elements of the system is.
Mhm.
So when you think about your architecture, you need to, but this is more software architecture topic, right? Where you really have to think about what are the use cases, what are the business processes you want to run, and where do you want to run them? And instead of having this huge amount of compute system sitting in one place where it's always on, and you have to have all these elements and business processes running, which of course is at the end of the day software, by separating it out and moving closer to the end users, you are able to give the users a way better experience if you want. But it definitely also help on the usage, right? Because typically when you start doing that, you again get the advantage that if you construct the systems correctly, when they're not in use on the edge, if you want, then they don't consume any power or anything like this. Whereas if it's centralized, it will always consume a certain amount of power to keep the lights on. So there's a lot of benefits to this. But however, it doesn't come without some work, because typically when you look at enterprise software, a lot of that enterprise software is based on very big, set monolithic code bases. So you need to start to unpick that to create and isolate the business processes, and then move them out of your core system into more distributed, if you decentralize systems, right? So that way you can actually have still a certain amount of processing going on centrally, but you can leave all the interactions more distributed out to the edges of the architecture, and then facilitate the communication back to the core system. That allows you to have a tighter core processing system that can run under a certain load. Since it becomes less and it's more scalable, you actually consume less power, you only do it on demand. And at the same time, by moving the interactions with the users out to the edge of the system, they won't be running 100% either, because people are not always there. They go off work after 8 hours, and then you can power it down and power it back on, right?
Mm-hmm.
So that's a great benefit where, if you look at instead of one big centralized system, having a more distributed systems where you move the specific parts closer to where the user actually sits and interact with the system.
Brilliant. And that being said, what would be your guidance then as to the type of architecture that you may use? I know, so for example, you mentioned software architecture, and you've got a school of thought that possibly could look at the Zackerman framework or TOGAF, and there's various other sort of architectures out there. What would be the right synergy to potentially consider, if you could possibly share?
Yeah, I can share. So it's kind of a religious topic to some extent inside the software. When you think about software architecture, the model I choose to use is a reactive messaging based architecture, right? So making sure so you sort of have everything is flowing around in messages and less on direct API calls, because the advantages of messaging is that you can actually have a better control around how you scale out your system, right? So that's my personal preference. Others have other preferences, and none of those, they go with an API approach, and then they have a gateway into it that can handle the scale on the back end. So each of those works. But I think the key thing here is that when you look at it, the first thing you need to look at, because it's not necessarily just a software architecture problem, it's also about what are the use cases, what are the business processes, right? And then you model your architecture around those business processes.
Mm-hmm.
And you have to think about how do you distribute them out, and then you put the pinning in place beneath it, typically in a new platform. And in my case, it's always been messaging that has been sort of the way we thought about it, and then apply that. And of course, you mentioned some frameworks you can use in order to ensure transaction integrity and so forth, that you need to put on top of this if you have that problem with distributed transactions, because by doing this, you will end up in a situation where you will have distributed data storage that you need to make sure is synced up with the centralized data storage. So there's a whole bootload of issues within this. But I think the first thing is to think through the construction of your system and how you solve the business processes, and what do you want to move closer to the end user, right? And then look at in my view, the providing a message-based system beneath, and then use services, of course, microservices, nanoservices, whatever, anything that fit what you need to do at the edge.
Absolutely, absolutely. Thank you for sharing. That's a very articulated approach with regards to basically getting the systems as close to the end user as possible and sort of using that decentralized approach. So yeah, brilliant. Thank you. So how can an organization achieve sustainability in its IT operations while also realizing financial benefits, particularly concerning CPU usage and storage?
But this is again, like we talked about a little earlier. It's really so. I think one of the key things here is that we if we take sustainability serious, right? Then, and I think we all do.
Yeah,
I hope.
yeah,
Then the challenge with the sustainability topic, because at the end of the day, we need to provide a business case or a business financial rationale for doing what we're doing, right? So when you start building your software and breaking it down and making it scalable, which means that there are some changes you need to do to your software typically to make sure it can do that, and you start breaking it down into smaller and smaller services, smaller, more granular services, you will end up in a situation where you can scale in and scale out, right? So that means that if your system is super scalable and it has a very sort of, very specific process being solved by a specific service, you can sort of not hibernate it. You can scale in and you can sort of ramp it up again when users interact with it. You not only do you lower by lowering the CPU consumption, you of course lower the emission, but the benefit of that is, from a financial perspective, is that you pay less, right? So it's kind of one of the interesting things where you could say there is a financial incentive to actually become more sustainable, and instead of saying we need to be sustainable because we need to save the planet. We can do that, but I think what people need to think about is actually, in order to promote that case, you have all the tools in the box to do that, because it's also it's financially better if you make the changes to the software. So you sort of get both at the same case, and then it becomes easier to argue why you have to make some fundamental changes, refactoring some of your software, because it's financially great, but it's also improving your sustainability. And I think that even what we need to get to terms with is the reality that there's going to be more and more focus. We're already seeing is the new legislation coming through the EU. You have to monitor and report on your emission. And this is one of the tools that can help you not only to be more sustainable, but it also helps your bottom line, which is something that everybody likes, right? So it's not like, oh, we have to invest a lot over here, it's hurting our bottom line. No. We invest a lot over here, and it actually helps our bottom line, and it helps the environment. I think that's sort of like the best place to be in, actually.
Yeah, absolutely. Absolutely. It is. Because obviously it helps the bottom line, as you just said. Absolutely. Brilliant. So what factors should an organization consider then when deciding between cloud services and on-premise infrastructure, particularly around from a sustainability perspective?
Yeah, so again, it's really about making sure, when you look at, let's take out whether it's one of how you actually host it, if it's in your own data center or not. What you need to think about essentially is that if you have a certain amount of requirement in terms of compute you need, and that is pretty constant, let's say you're always sure you're using 60 to 80% of your capacity, then you may be better off having your own systems, right? Because you actually are capable of getting the biggest utilization of those said resources, so you don't need to have them sitting idle, right? Because in any shape and form, idling machines, it's like you're idling your car, it's emitting CO2, and you don't want to do that. However, if you're in your on-premises state, you can guarantee that you have a certain usage, I would say beyond 60, 70%, then okay, it's financially and sustainability probably easier just to keep it on premise, depending on your investment. Because when you move things to the cloud, you of course pay cloud tax, and
Yeah.
people forget about this tax you pay because you have to pay for that. Somebody needs to make money on it. Whereas if you buy your own machines, you buy them and they sit there and you utilize them to the extent possible.
Mhm.
If your workload is more varied, that you need to be able to scale in and out, and you cannot get to like a 24/7 utilization at a high percentage, then my view is you should start moving to the cloud and making sure that you can actually have that scale, because then, but again, back to your software needs to be able to do that, because then you can scale in and out depending on the demand.
Yeah.
That's the third scenario is the hybrid scenario.
Yeah.
That's a really valuable scenario as well. That's where you can say that to a large extent, I can exploit my on-premise
Yeah.
or my own data center, but there are some peaks. And then if you then support the ability for the software to actually dynamically go and acquire resources, compute and storage in the cloud, then in times of peak, you can then move some of the workload to the cloud and then shut it down when you don't need it anymore. I think that's kind of like how I think about this.
Absolutely.
So again, it depends, right?
Yeah, absolutely, absolutely. And I think what you're alluding to also, it looks at, you're basically affecting the total cost of ownership and the environmental footprint by, looking at those potential strategies. Okay.
Yeah, because that helps your total cost of ownership, right? Because you bring, it's about optimization essentially, right?
Mhm.
And we have, with the cloud, with all the tools and technologies we have today, we have a way better control about our costs.
Mhm.
If we think about it early on, if you're building that new, if it's a greenfield, you build something that new, these are the considerations you need to start thinking about when you're architecting your software. If you have an existing system that is, 10 years old, it's built to a different model where you have it in an on-premise environment, and you need to consider, do we spend time breaking it down? And one of the key points is here that it always depends, right? So there's tons of different use cases out there. But when you start looking at it, yes, this is one way you can improve your total cost of ownership. That means that you can you can estimate what is the price for making, the refactoring or whatever you need to do, and then you can hold it against what are my calculated savings by doing so, based on how the software operates. But there's a lot of upfront work you need to do in terms of looking at your system, understanding the process, what are the pieces and then you can start calculating what is the cost of owning it and what is the best model for you going forward. And then you can also get an idea about your return on investment.
Yeah, absolutely. Absolutely. Okay. So how has the increase in tooling affected the software development environment in recent years?
The tooling, so there's various means of tooling, right? I think whenever there's tooling, it helps you to be more efficient if you want in various areas, right? So it's all about helping engineers and helping operations people to be more efficient. So it has definitely made it possible to produce systems faster, and that keeps happening. I think what we are seeing recently is that there's a lot of emphasis putting into the sort of the tooling. First of all, of course, there's the tooling help you write code, but there's also a lot of work going on. How do we help engineers be more efficient in the areas that sits around actually coding, like pipeline deployment, quality control? How do we? That will help significantly in producing better software. I think better quality software, right? Because you can now use technologies to help you construct test cases, automated tests, and so forth. And some of these are, of course, driven by recent advances in AI or machine learning, if you want, particular, that can help that. So I think that there is a lot of effort putting into tooling to improve the developer experience, that's called. And most companies of a certain scale today also have internal groups within the engineering teams that actually focus a lot of our development experience and how do we apply the right tools so we become more efficient, right? I would say though that one have to be careful to believe that we don't need engineers going forward. Engineers may be doing other things as well, producing code, but we have to be careful about not relying too much on these technologies to write the actual code, because that typically there's some study and research that shows that it in some cases actually produces insecure code, faulty code, and so forth that can be very hard to debug afterwards when you put it in production.
Absolutely. Copy and paste is not the way, especially with regards to code generation. So yeah, absolutely agree.
Yeah. And now I'm probably going to say something very controversial here, but I think a lot of the things that are coming out of those code generators, you might as well just copy paste from Stack Overflow, right? You know, and I think it's a good tool, but it does require that whoever uses this is capable of reading code and understanding code very quickly and can sort of think through it. And what does this code do? How does it impact the rest of the system? Because these systems cannot do that yet. Absolutely. So you need to be able to reason about the code.
Yeah.
Agreed.
Brilliant. Okay. So how does Unit4 tailor its solutions to meet the unique needs of the European public sector with a focus on people-centric outcomes?
Right. So just for the audience, right? So we are focusing on people-centric businesses, which means that, for example, public sector is a big market for us in Europe. And the interesting thing about, I would say the question is probably broader, or my answer was cover a broader topic.
Yeah.
What we are seeing today, and I think everybody is seeing this, is that there's a higher and higher scrutinization in terms of your security, right? What is your security measures? How do you keep the software secure? That's one thing that's really taking off. Mm-hmm. Second is the protection of individuals' data and you know, like the GDPR and other measures, right? How do we make sure as software vendors that our software is secure, you can't breach it, and also there is no access from anywhere into actually seeing the data. So it means that when you provide cloud-based software, it's not just about providing the capabilities in your software anymore. It's also about the totality of your system, which is broadening out to enclose not just the production, but also the deployment, the running, and the security around this. So we are spending, not just us, I think everyone is spending a fair amount of energy providing internal tooling to make sure that when people are supporting the system, that they have the right level of access without violating any of the current legislation coming in place. So coming down the pike, like the DORA and the electronic banking that the EU is putting out. And the same goes for AI. So what we are seeing is that there is a higher degree of expectations when, you know, public institutions goes to tender that we need to honor, that's actually beyond the software. So a lot of our energy today is also about those topics to make sure we are compliant and the data is secure and we have the right measures in place to actually do that through various certification like ISO 20001, there is 9001, and there's a very NIST 1 and 2, for example, that we need to adhere to make sure that we can actually sell into public sector in Europe.
Yeah, absolutely agreed. And, you know, IT Labs, we are at heart a software development company, but we are a talent growth company as well. And what we've seen is that we've had to go and acquire 4 key ISOs. So that's 27001, 14001, 9001, and 27001 for security. And you absolutely need, you know, those types of ISOs in order to, you know, engage in public sector activity, or depending on the size of enterprise that you're dealing with, you know, they may require that as well from a sort of standard perspective.
And there's also other requirements, like, for example, data residency. So we need to have data centers. And so, for example, if you want to sell into what, you know, like police and so forth in the UK and Ireland, you need to have people who are vetted through M5. You need to have a local data center. You need to have local personnel. You can have people outside the UK, non-residents, actually having even access to the system. So there is a lot of these things you need to accommodate in order to sell into what we refer to as the public sector. And of course, we're doing all that.
Absolutely, absolutely agreed. Absolutely agreed. Brilliant. So, how did the pandemic influence attrition rates in the industry, and what factors would you say contributed to the most or to post-pandemic stabilization?
I think it's an interesting topic, and I don't think there's only one thing. I think there's a lot of moving parts here, right? But what we saw was that, of course, the pandemic came and everything. Everybody was just hunkering down. Nobody really wanted to do anything. Was going to stay here.
Yeah.
But as part of the pandemic, a lot of emphasis was put on digitalization, right? And that actually drove up. So when things started to roll up again, there was a huge amount of energy putting into digitalization. We saw new platforms. This whole everything is going to be remote. That spawned off a ton of new solutions coming out, and attrition went through the roof, right? So most companies ourselves had to put some measures in place to deal with this. We had some areas where we had like 40% attrition, which is very high and very hard to deal with because you lose too much knowledge all the time. What then happened was, I think, post-pandemic, a lot of sort of the early there, a lot of investment was going in. People were ramping up, and then all of a sudden you see the opposite, right? Now, now we are starting going back to the office. Things are starting moving back to the old. To some case, some companies is still full remote, like ourselves, or semi-remote. But there is this going on, and all of a sudden, all the big tech companies started sort of readjusting their workforces. So now what we're seeing now is attrition is really dropping again to very, very low rates because of that dynamic. So I think we saw sort of a bubble, and then it went away, and the bubble drove up attrition, and then attrition. So we are sort of, I would say currently, at least in our situation, and I think in many companies, the attrition is below pre-pandemic times at this point, right? But that was sort of kind of what was caused this sort of kind of first down and then an up, and then now back down again, where everybody is again looking at what's going on in the industry. And also there's a lot of uncertainty right now, right? Because what you're seeing is, of course, driven by, to some extent, I'll say the hype. People are trying to apply AI technologies to do a lot of the tasks and everything like this. But I think my view is it's probably predominantly driven by efficiency concerns. And then you're sort of trying to think about the future. You can apply these technologies. But I'm pretty sure that down the road, when we start understanding exactly where we can apply these technologies in the development process, we probably will see an uptake again, and people are going to start hiring a lot of software folks back into the companies.
Absolutely, absolutely. We see exactly the same thing in IT Labs. We are a concierge to the technology leaders, and we follow that sort of scaling and as you just alluded to, sort of the ups and downs and the peaks and troughs of the attrition rates. And so we absolutely agree and see that as well. Brilliant. Okay, so how can organizations ensure effective management of a distributed computing environment when using technologies like .NET and Java?
I think when we talk about management, right, it's about how do you set up and run it, right? And it's not really super tied into the technology. I think some of these topics are technology agnostic, because it's really about how do you manage your estate and how do you build this out, right? And what it does require, I would say, is that a lot of companies really, so sometimes we have a tendency to go out and build stuff, but actually when you look at a distributed system and how to manage that, you need to really have great deployment capabilities, like using deployment technologies, build pipelines and automation. You also need to, in the software, you also need to make sure that you have sufficient telemetry available so you can measure and monitor how is the software operating in a distributed environment. And how do you secure it from an infrastructure? So I think one of the things that will ease the overall management, at least that's our experience, is to and it may sound a little, it's not a new topic, but it is really infrastructure as code, right? You need to make sure that everything can be deployed through a pipeline, and you can stand up the resources or the services and get everything configured and set up automatically. That's the key topic, right? And what we found when with our new ERP solution that we built, that is a true multi-tenant superscaler based on everything I talked about,
Yeah.
is that when you have those systems, and bear in mind we a software vendor, so we deliver our services to. So we don't. I'm not in house, right? So we are
Yeah.
digital native, if you want. Um, the You need like in order to maintain and run our multi-tenant solution, we probably have 5% of personnel compared to what we have in our non-multi-tenant super scalable solution, right? So this whole trend, and this is not just about the software being multi-tenant, but it's also about when we start building this, we made sure that we put automation around all these non-coding elements, which is the deployment and setting up, so the whole DevOps journey, and that is hugely beneficial from a management perspective. But you really need to automate everything, right? So you need to
Yeah.
treat everything you do as immutable. You can't, you redeploy, you don't change. So it's always depending on where the system sits or the different constituents of the system, they're always the same. It's the same thing that runs everywhere. It can sound maybe a little rudimentary, but apparently based on talking with other people, there's still a journey to go, but that's really how you do it. There are so first of all, everything is automated. It's immutable. You don't change anything that's running. If something needs to be fixed, you roll it forward, and that means you roll it forward across your whole estate, so it's always the same. You make sure you have sufficient automation or automatic capabilities in your offerings so they can actually self-heal. So we constantly measure services to make sure that the health state is at a certain level. And in case, for an example, something goes off the rails and disappears or whatever, then it reboots itself or reinstantiates itself. So all these elements need to be in there. And that is actually how you get to a way better management of your estate, right? But I think one of the keys, and then you only have one code base. You have one code line that you work on. You don't have multiple code lines. It's also one that helps not just your management of it, but also in general your whole value chain from product to engineering to cloud operations, right?
Yeah. Absolutely. Great. Thank you, Klaus. That's really a sort of informative approach to understanding how .NET and Java can be used when you're looking at sort of effective distributed computing environments, using obviously the likes of .NET and Java. So thank you for sharing. In terms of your experience, how can AI be integrated to enhance outcomes, i.e., business use case objectives, whether it be in any particular industry?
I think this is a great topic, right? I think when I think about AI, I try to think more about automation in general, right? Some things, there are workflows and processes you can automate without using these technologies, right? But I do believe there is a lot of value to be found in general by automation, right? And I think in our space, which is ERP software, the reality is that ERP is really a one big state machine, if you want, right? So, and you can, for a large extent, automate those states and hence automate the processes and hence actually give people time back to do more interesting stuff than actually using ERP. So just a little thing here. So if you think about the world I'm coming from, a lot of ERP software is built around essentially data maintenance, right? You enter data, you do data maintenance, and it came from a time where there was not a lot of like centralized integrations going on with the public sector or other companies, and invoices came in as paper invoices. So a lot of stuff we're seeing is actually based in that time and sort of being moving forward. But what happened now is that all that is getting electronic. For example, in Europe, you cannot interact. If you're a business, you cannot interact with public sector without using PayPal and similar. So you need all this is already automated. So what you really have is you have a great opportunity to remove some of the manual steps in the business processes and automate them based on that. In some cases, of course, machine learning or AI can be applied. And it's actually been going on. I don't think people really think about it. But a lot of the products coming out where you did OCR scannings of invoices and so forth, that was actually already an element of machine learning getting into that. So what's happening now is that you can apply more interesting use cases, because sometimes when your data is not exact, then you can use machine learning to actually help out doing account prediction. So there's a Danish company here called Count, actually, here in Denmark, that have that ability, with whom we're also partnering. So you can remove a lot of manual steps in making sure that you have the right account settings on the inbound. Even though they come in electronic, you may have to do some work. That's a way where you can really take a lot of manual steps out of the processes and that do through machine learning, and that actually enhances outcomes. We're also seeing it in expense management. It's a great place as well. And we have, as you can see it when doing timesheets, because you have to, when we serve public sector, we serve, consultancy companies like professional service companies, and they do spend a significant amount of time doing timesheets, because for commercial customers, this is what they invoice on. So what we're looking at there is how do we automate that piece so people don't have to do that? And that actually saves a lot of time as well and improves the outcome. And people, in our view, can go off and focus on topics that actually serves either the communities, the citizens, or the customers by automating these processes through increased automation. And one of the tools to do that is, of course, using AI and machine learning. We're also doing it to create, for example, we have the ability that you could look at get it to look at a specific key points in your reporting and create narratives that's readable. And this is where Gen AI is really helpful. So it gives you a story, if you want, that explains your company's performance in a better way, and you can save time because it based on the KPIs you're giving it a case on a little guideline. It will come out with a report, financial report that actually contains a nice narrative people can read, so you don't have to spend time on that. What else can I mention of interesting elements we are working on? Further optimization around payroll is a great area for us, right? Where we're doing a lot. We're also using it in our new performance review process, where you then can have Gen AI pick up elements of your performance reviews and then create create what are the points I need to discuss with the employee. That's a great time saver as well for managers. And it's not cheating, right? Because it's just helping you take the data and then create a story for you or a narrative that you can then use to explain. Skill mapping, for example, if you are in a project organization, you have employees, they have skills, there's history, so you can make a automatic suggestion to the best resourcing based on people's skills, their tenures, previous projects, how does those project go, and then you can actually get we have the technology that will staff projects based on that. So we'll give you a suggestion that also takes into consideration other tasks and other projects running. So there is a ton of potential here in terms of improving the automation within these systems, such that employees can, do more valuable work in serving communities and customers and so forth. Students, we also in higher education. Yes.
Absolutely, absolutely. Do you know, I've seen in whether it be the construction sector, you may have a scenario where a construction company has been tasked with building, let's say, for example, 500 homes, and that is then subcontracted to other players in the market. However, the challenge is that these subcontractors have to go out from the various merchants and purchase materials. Now, in some instances, they would like to have an environment where they could see all the materials available, at price level that is needed. So, say, for example, if the specification of the building meant you needed 6-inch nails, where can I buy 6-inch nails from, say, for example, 10 or 15 vendors, merchants, to then get the most accurate pricing that's most cost effective for them? Because then it depends on, how much material they can get into their vans that they can then bring on site in order to do the job. And in some instances, based on the flexibility of not being too precise with the materials needed, i.e., the next best fit. Sometimes it's that's in essence is a challenge for some, whether it be contractors, and AI can potentially solve that in terms of formulating what is the most optimal.
Yeah.
Yeah.
No, but it's kind of it's abstractly speaking, it's the same, right? If you
That's
have an
right.
employee with skills on project here, you just have a different material, right? But you still need to source the best, whatever the best is, based on some
Yes.
parameters.
Yeah.
But I think the interesting thing about a lot of stuff in the world is that, the ability to apply these technologies today, there's a lot of reasons to it. First of all, it requires more compute and everything like this. However, in order to actually get to this, something had to happen first. And what happened first was bigger integration, more electronic data flows, right? Because otherwise, you wouldn't be able to go get the electronic catalogs. You're talking sort of a sourcing, it's more like supply chain, but you would have to go source that data, right? So, and it needs to be current because the sub-suppliers are interesting to have the most current data there so they can actually get their product sourced, right?
Yeah.
So all that had to happen first before you could apply what we're applying today. So there's always this sort of like, because we could 20 years ago think about how, no, this would be really cool, but it was not possible at that point because you couldn't get to the data. So let me go back to the I don't know so much about constructing houses, but I know more about getting the right people on the project. So the interesting thing that needs to happen there first, and this is specific for our space, was that about 10 years ago, we looked at what I just talked about. We looked at how would we be able to do that and actually give these automation capabilities to our customers. At that point in time, our customer was on-premise, right? We had an on-premise system. And the problem with the on-premise system was that they mutated, right? There's not two on-premise ERP systems that's the same. They have mutated, people have changed, they have used the database for something else, they may have changed the semantics around columns. So it meant that but in order for machine learning to work, things needs to be stable. You need to have the same data element of features, or as they call in that area of the world, in order to actually run the algorithms, right? Mm-hmm. So what needs to happen first was that first we needed to build our new ERP, which is a multi-tenant system you cannot mutate, which means that the underlying data structure is stable. Mm-hmm. And everything is known. Then you can start applying these technologies, right? So and that means it all started way earlier than that. It started when we said, everybody has to move to the cloud, because as part of moving to the cloud, we got all the data in, so we get the access to all this data, so we can start mining all this data, and we can start logging it down, otherwise we can't apply it. So it's kind of like it had to go through this nearly 20-year long process to get us to where we are today, right?
Absolutely.
So I guess, so there is all these bits and pieces that needs to fit together before you actually get to the point where you can say, oh, I told you so, right? But yeah, we knew we could do that, but it's just all the bits and pieces you need to align took 20 years to get aligned to get us there. And it's kind of interesting how this works.
Absolutely. Absolutely.
And this is also, again, it is about making sure you have one system. It's always the same. It's immutable, such that you can actually apply these technologies. So you cannot allow customers or tenants to go in and mess around with the data model or the meta model.
Yeah. In essence, it's about, whether it be creating one data source by using the cloud in terms of, having everything put in one place that then enables you to possibly apply, whether it be algorithms and various other models to improve or optimize delivery pipelines or looking at achieving, better performance in the
No,
organization.
and this is sort of the same as we talked about a little earlier in a conversation around what we're seeing now is all these new technologies coming out that helps you do code. For example, all the code stuff, that's because it's available, you can mine it, right? So you can actually get to that. The same with the testing capability, the same with the pipeline building, the same with the KPI meeting, and the same with checking your health state. Because checking the health state of your software, it's the same problem, right? If it sits on premise, you have no idea what's going on because it's customized to the nth degree. So whatever you think is when you build something, well, it won't work because the customer decided to change some attribute, right? And the whole thing falls apart. So it's really, so when some customers or people are complaining about they have to move to the cloud, yeah, it's understandable, right? Because they have to move to it's a different way of thinking about your systems because now they sit somewhere else. They're not behind a locked door on you on premise. But all the benefits you get from this is crucial because you won't get those benefits if you insist that you're special. Sorry, and that's just going to happen because they cannot be applied, and you will lose out on a ton of innovation that's coming as a function of 20 years of migration, if you want, and technology building and integration and electronification and so forth to get you to this point where you in the cloud can get access to innovation. And going forward, the innovation is built around those technologies. So if you're not where they are, you're left back on the station, right? Yeah. And also, it gives you better more sustainability. So it's a no-brainer.
Yeah, absolutely right. Absolutely right. In essence, you're saying that the foundation's been laid by, us going to the cloud in the first place. And then those, say, for example, ISPs, the likes of AWS, Microsoft, Azure, etc., who have then looked at building a solution in the cloud that further optimizes your environment, means that there was so much benefit and gain to be had by organizations going to the cloud. In some instances, it does warrant to have an on-premise environment, especially if you've got critical core technology. But in some environments, the cloud is absolutely, the sort of the place to be if you want to sort of enjoy some of those operational efficiencies and just basically just less heart headache in terms of wondering whether or not you can keep the lights on, as some might say.
I remember some years ago, I was talking with some analysts and I used this phrase, in the cloud, nobody can hear the vendor scream, right?
Yes.
Because it's the vendor's problem. Integration is the vendor's problem. It's all the vendor's problem. Think about it. There's a ton of issues you don't have to deal with. It's just disappeared.
Yeah.
Right.
Yeah. Brilliant.
Somebody.
Okay. Say again, sorry.
Yeah, I don't know if you're the Douglas Adams fans from. I think it's from the Hitchhiker's Guide to the Galaxy.
Yes.
They talk about this SEP field around spaceships, so you can't see it. The SEP field stands for somebody else's problem. I don't know if you read the Hitchhiker's
Yeah. No, I used to watch it, Hitchhiker's Guide to the Galaxy, absolutely.
Oh, okay. Yeah. If it's probably in there, but anyway.
Brilliant. Okay. So what are the key, and this is our final question. So what are the challenges in both finding practical use cases and more so for implementing AI technologies within an organization? Because and just to give you a bit of context to this is something where, we are speaking to organizations who want to introduce AI. However, it's like they know the problem they need to fix, but they're not sure how to go about fixing the problem using AI.
That's a great question. I think, if you know your use case, right? If you know what you want to do, I think that actually I don't know. I think many situations, what at least we're finding is that it's not always obvious for what it is you're trying to solve, right? But I think
Yeah.
if you know what to solve,
Yeah.
if you know what the problem you're trying to solve, then you can put the right people on to understand how to solve that problem, right? But you need to formulate what it is you're trying to solve, right? And in and now there's two schools of thoughts here, right? So there's one thought where people are saying what you can do, and this is typically where what you did when you were on premise, and you have your own system, you have configured it, you probably have customized it to some degree, so it doesn't really look like what the vendor provide. Then you can always apply like robotic process automation tooling to automate steps, right? That's just one technology you could use when you understand the use cases, right? And we are from the school of saying that automation needs to be intrinsic. We believe it needs to sit inside and not be added on top of the software, but you need to, from our perspective, from the vendor, to make sure you put the automation in place and the technologies for users to piggyback on those technologies through openness in a platform that allows them to apply machine learning to other processes that sits outside the core system, it's the core ERP system itself.
Mm-hmm.
But if you know the problem, you know what you're trying to solve, and then how you're to implement it, you can find people to do that. Look at the data, find out if that data science. You can look at the engineers can build the code that's needed and so forth. So I think most people are struggling understanding what is it we're trying to do with this. What's the problem we're trying to solve? How do we formulate the problem? The problem formulation seems to be the hard point to get across and totally understand how could I do this differently. That I think that's at least my experience. You'd seem to have a different experience.
So yeah, no, that's absolutely right. And I mean, I'll give you an example. We're quite heavily involved in the housing sector in the UK, the social housing sector. And in some environments, it's a worthwhile endeavor to look at if there is a way of understanding the health of a building. And typically what that would require is somebody going to that building and carrying out some form of assessment, whether it be on the assets or some form of inventory, etc. But is there a way of, say, for example, having drone technology fly, and just imagine if a housing association who manages, say, for example, 50,000 homes or 20,000 homes, 15,000 homes, 5,000 homes, is there a way of using drone technology flying over the street and where the property is and getting a look and feel, just basically recording the building itself, just as it visually looks, and to understand whether or not there's any cracks or, are there any like shadings in the brickwork or anything that would warrant someone going to the building to further investigate if remedial works are needed, especially if you've got a high number of buildings to manage. So, the idea was looking at how AI can be used to, whether it be collect the data, with the data's been collected, but then have a sort of algorithmic model that is able to establish whether or not there is an issue with the building, if I can say it like that.
Oh, yeah, but so this is more in the field service management part of the world, right? I think there's a lot of things you can do, right? I think there's a lot of today, if you have any appliance, any whatever circuits, they can be monitored electronically, and you can measure if there's anything wrong with the power, anything wrong with anything, even refrigerators, they have health check if you want, right?
Yeah.
So I think from all these where you have its capabilities in terms of Wi-Fi enablement, you can monitor most of what's in a building today. I think you can do that. I think what you're talking about, having drones flying around, I think you're going to have no problem with that. I don't think people are going to like that, to be honest. But definitely I think you could do that, right? If you film a building, you can analyze it to like the facade and everything to understand